Hello, this is Andrew from Sprog DCC. Welcome back to the channel. In this video, I'll show the Servo IO LCC being used to control servos. Two servos are connected to bank A. Jumper J4 is set to pull down the servo control lines. Some servos may require the control lines to be pulled up to avoid glitches at startup. To show local control, a button-led test board is connected to bank B. On the real layout, this could be a control panel. It should be remembered that the control inputs do not have to be connected to the same node on the servos. They can be on another node, or a so-called glass panel using JMRI for example. We'll look at that in a moment. We'll start by looking at the options for local control. When I press and release button 1, servo 1 moves between its two end positions. This is to simulate the use of a toggle switch, with the button pushed representing the toggle switch closed, and the button released representing the toggle switch open. One servo can be controlled by one I/O channel in this way. The current servo position would be indicated by the position of the toggle switch, and also the LED. Each time I press and release button 2, servo 2 moves from one end to the other. In other words, the servo position is toggled between the two endpoints for each button press. The LED associated with button 2 is on or off to represent the servo position. Again, one servo can be controlled by one I/O channel. It's also possible to have individual button control for the two servo positions. Here, buttons 3 and 4 are used to select the two servo end positions. Their associated LEDs indicate the current position. In this mode, two I/O channels are required to control one servo channel. You can see that the LED for button 2 also reflects the servo position, since it's using the same position reporting events as buttons 3 and 4. Here I am using a remote IO LCC node to generate the events to control the servos. Bank A on the IO LCC has been configured to produce and consume the same events as were used for local control through Bank B on the Servo IO LCC. This is easily achieved by copying and pasting events between the two nodes. And here I have added a couple of turnout icons to a JMRI panel to control the two servos. The Servo 2 output toggles on a single event, so I created the turnout using the same event for on and off. To get the panel display to update correctly, I created a sensor and linked that to the turnout. I'll now go through the Servo IO LCC configuration for the operations just demonstrated. Some familiarity with LCC and JMRI is assumed for the remainder of this video. I will build on the concepts that have been covered in some of my earlier videos, which I recommend you review if you are at all unsure. Bank A has been set for servo operation. With the current firmware, all channels of Bank A operate in the same mode, either I/O or servo. For the basic toggle switch setup, I want Bank B, channel B1, to control servo 1 on channel A1. Producer P1 on bank B1 is given an input on action, and then the event is copied to bank A, consumer 1, with an on action. In a similar fashion, give B1 producer 2 an off action and copy the event to A1 consumer 2. With an off action. Remember to save all the changes and mark the update as complete. And that's it. You have configured one input channel to control one servo. For toggle control with a single push button, I want B2 to toggle the position of servo 2 on A2 with the LED indicating the position of servo 2. Set B2 as button-led, output with sampled input. B2 producer 1 has an on action and is copied to A2 consumer 1 with toggle action. Select servo on position action on A2 producer 1 and copy the event to B2 consumer 1 with off action to control the LED. Similarly, select the servo off action for A2 producer 2 and copy the event to B2 consumer 2 with on action to control the LED. The on and off actions may appear to be the wrong way round, but remember the LED is active low and will illuminate when the output is turned off. For control with individual on and off push buttons, with LED indication, I will use B3 and B4 and set these to button LED output with sampled input. B3 producer 1 has an input on action and the event is copied to A2 consumer 3 with on action. B4 producer 1 also has an input on action and the event is copied to A2 consumer 4 with off action. To indicate the servo position, we use the servo 2 on and off position producer events from the earlier position toggle setup to control the LEDs. Copy A2 producer 1 event to B3 consumer 1 with off action and also to B4 consumer 1 with on action. Copy A2 producer 2 event to B3 consumer 2 with on action and to B4 consumer 2 with off action. Again, the on and off actions allow for the active low LEDs. Remember, always save changes and update complete. There are currently two ways to set the on and off positions for the servos. We'll first look at using the node configuration dialog. We need to open the servos on bank A segment in the configuration. There are 8 tabs labelled S1 to S8 for the 8 servos. For each servo, you can enter the off and on positions and the off and on speeds. The position can be a value between 0 and 250. This represents the servo control pulse width between 1 and 2 milliseconds. A value of 125, for example, would set the servo to its mid position. The speed can be set between 1 for slowest and 7 for fastest. At startup, each servo can move to one of a number of positions or do nothing. If an event is consumed by multiple servos, they may move all together or sequentially. Sequential operation is recommended to reduce power. For analog servos, it is recommended to set the power down option when the servo has completed movement. This is also recommended to reduce power consumption, but does not apply to digital servos. Using the CDI to set the servo positions is not so useful if fine position setting is required. Servo setup mode uses a button-led test board or similar hardware connected to bank B. Press and hold the blue button until the LED begins flashing. Servo setup mode is documented in the Servo.io LCC user guide. Select the servo to be adjusted using buttons 1 and 2. The LED that flashes indicates which servo is being adjusted. Button 7 selects the endpoint to be adjusted. A long on and short off flash indicates that the on endpoint is being adjusted, and vice versa. Buttons 3 and 4 are coarse adjustment of the servo position, and you can see the servo arm moving. Buttons 5 and 6 are fine adjustment with barely perceptible movement. I'll now move the arm to the end of its travel. Button 7 is used to save the setting for the selected servo. You must do this after adjusting each end position. Once you have adjusted all of your servos, exit setup mode by pressing the blue button again until the LED stops flashing. Here I'm testing the new positions for servo 1. It should also be possible to enter servo setup mode by selecting it as a bank type for bank B, but this is subject to an errata and should not be attempted if the Servo IO LCC firmware is lower than version 1.6. That concludes this look at using servos with the Servo IO LCC. Thank you for watching, and I hope it was useful. Please leave any comments you may have down below, and look out for our future videos.